Welcome to the Purpose Nation podcast, inspiring conversations with Christians in science, technology, and industries of the future. For more information or to make a tax-deductible contribution, visit purposenation.org.
This is Brad Cooper with Purpose Nation, and today we are thrilled to be joined by theoretical physicist Professor Gerald Cleaver. Professor Cleaver, welcome to the Purpose Nation podcast. How are things in Texas going today?
They're going well. Thank you, Brad. Thanks for the opportunity, and just call me Jerry.
Okay, I will. Happy to honor our guests in any way they'd like to be addressed. So Jerry.
Thank you very much. I appreciate the opportunity to discuss science and theology with you today.
Thanks again for joining us. Looking forward to it as well. Should be some interesting topics and discussions on faith and science, and maybe talk a little bit about space travel. I saw that on there, and that always jumps out at me, and so I saw some things there in your background. So first, by way of background, a little background on Professor Cleaver. He is a professor and a graduate program director in the Department of Physics and division head at the Center for Astrophysics at Baylor University. He directs there the Early Universe Cosmology and Strings Division, as well, and I guess that's UCOS. I don't know if that's how you pronounce the...
UCOS as the acronym for it.
Okay, and then also Baylor's Center for Astrophysics, Space Physics, and Engineering Research, which the acronym is CASPER on that one.
Yep, yeah, and UCOS is the division I lead in CASPER.
Okay, great. And I always love the acronyms in science.
Baylor loves acronyms.
And don't worry, we have a lot of those in the technology, in the tech industry as well. So acronym city. Jerry has written over 100 peer-reviewed papers and articles in many top-tier research journals and conference proceedings. He co-authored a book. He earned his PhD at Caltech, real top school for physics there. Lots of great names have come out of Caltech, including John Schwartz, who I guess is one of the founders of string theory. Is that right? That's somebody.
That is correct.
As well. And he does focus on superstring theory and string theories, as well as elementary particles and fundamental forces. And as we'll talk about here, I hope, in a minute, some interesting interstellar propulsion mechanisms and things like that. So lots of great background there and some fascinating experience. Tell us some of the main things that you're working on currently. What are some of the main research projects or areas of research that you're currently focused on?
My long-term research, again, continuation of the PhD that I earned way back in 1993 under John Schwartz at Caltech, is a specific aspect of string theory. String theory is interesting and controversial topic that suggests that the universe that we live in is not just three-dimensional, but has some extra but very, very small and essentially undetectable dimensions of space. And it proposes a version of sort of a grand unified theory that offers an explanation or description of all of the forces and particles that we find in this universe. More recently, I've been doing research with my colleagues here on something called quantum gravity, of which string theory is one possible direction in. We've been working on ways of detecting the state of the universe prior to the Big Bang.
That's definitely interesting, because my impression has always been that there wasn't a state of the universe prior to the Big Bang.
Quantum gravity in various different approaches actually suggest otherwise. And some suggest that at the beginning of time, it really was what we'll call time zero, but that there was likely even time within our universe preceding that.
Interesting. Okay. Well, I'd like to hear more about that in a minute. Now, so you're also at Baylor University, and how long have you been there?
I came to Baylor from Texas A&M back in 2001. Following my earning my PhD in 1993 at Caltech, I did postdocs at Ohio State University, University of Pennsylvania, and then Texas A&M for 2 years, and then visiting assistant professor for one, and I came to Baylor from there.
Right, great. And they're a Christian university, yes?
Baylor is, yes. Baylor is affiliated with the Baptist denomination, and I say affiliated, it is most closely affiliated with the Baptist General Conference of Texas.
Okay. And now this is a graduate physics program as well. At least to my mind, it doesn't seem like there's a lot of, at least top programs. I know there's probably some programs that are undergrad, but in terms of graduate physics programs at Christian universities, are there many?
Each denomination tends to have at least one full university with graduate programs. And Baylor is the largest of the Baptist universities. Baylor likes to think of itself as, in some sense, the Protestant Notre Dame.
So obviously Notre Dame's Catholic Christian roots to it. They obviously have some top programs in science and physics. I wish there were more, I guess is what I'm saying, because it does seem like a great option
We are trying to be one of the leading Christian universities with research. Decades ago, Baylor was predominantly a teaching university, but starting a little over 20 years ago, it began the transformation into a research university. And currently, we have Research 1 status, and our goal as part of the next 10-year program is to advance to Research 1 is also known as high research. We are trying to advance to what's now classified by the Carnegie as highest research status. To do so also means basically increasing our rank to one of the top 50 universities.
Specifically for the physics department, it seems like you're definitely growing that, and the grants that you've gotten, it seems like there's a lot of growth there. Yes?
It has. We've been growing and developing quite well since 2000 or so.
Okay. Well, so take us a little bit back in time, maybe back into the childhood or wherever it might have been where you decided that you wanted to get into science, and then maybe more specifically physics.
I knew by early years that I wanted to be a physicist, and more specifically astrophysics. And I will sound like a typical nerd. I think one of the things that did it for me was Star Trek.
Okay. It's very common. I was more of a Star Wars guy, but Star Trek, at least the movies. Okay. So, and it's always been sort of astrophysics. So the space and space travel and the stars, and that was sort of your thing.
To me, there is quite a bit of overlap between elementary particle physics and astrophysics / cosmology. And my degree ended up being in string theory, which has both some elementary particle aspects and some cosmology aspect, involved in both and interested in both areas.
So science fiction, any members of your family that were either in science or math or in education? That's a common one that I also hear.
My father is a retired aero engineer who worked with the Department of Defense Civil Service after being in the military for a few years.
Okay.
So yeah, right. And so that was one science side.
And then math as well. Was that an area of interest for you? Was that something you were strong in through college even?
It was. And that was one thing that led me to attend Valparaiso University in Indiana for my undergraduate degrees. I have undergraduate degrees in physics, mathematics, and I also have many philosophical interests. So I was a member of Christ College Honors College at Valparaiso.
Oh, well, I was going to ask, so was there a point in maybe your life or career where you thought about maybe potentially other careers? I mean, one common one we hear is, for Christians anyway, is sort of the debate between, do I go into ministry or do I go into the workforce, into industry? Was that ever?
That was. And in fact, that was, to be more specific, I also started out as a pre-seminary student at Valparaiso.
Okay.
Another reason for going there. I am of Lutheran background.
What sort of caused you to go in one direction or the other? Or, how did that happen? Where you still obviously, can live out and practice your faith in the career that you're in. And that's sort of one of the messages we come across with Purpose Nation. But what was sort of the thing?
It was, and I think that's a good emphasis. I felt drawn in both directions during my college years. By the time I was junior, senior, I realized that my deeper interest was sciences, but the related theological aspects. So I've always been interested in, I think, understanding the two books, Book of Science and Book of Theology, General Revelation and Special Revelation.
And was there a point, was it in college or where you just sort of firmly put your foot in the science, more firmly, I should say, into the science camp versus going down the path of becoming a pastor or some other kind of...
junior year at Valparaiso. And I think some of the courses in the Christ College Honors College really helped me to affirm that.
And any other interests or things that people might be surprised? So I saw something about model aviation, sailing, maybe even some taekwondo. Is there any other musician maybe? I don't know. Was there any other potential career for you, or was it always really just so solid in science that there wasn't even like a second choice?
I really enjoy those areas. I don't have enough time to spend on any of them. I do like radio-controlled model aviation. I have a couple of sailboats, a Sunfish and a Snipe.
Okay.
I was in karate years ago, but been wanting to get back in. I stopped at Blue Belt and haven't been able to go further.
Well, that's further than me. So, and then also let's talk a little bit about the faith background. So it sounded like you mentioned Lutheran family.
Yeah, I grew up in the ELCA division of the Lutheran Church, and which is again why I chose Valpo. It seemed clear to me. I wanted to go into the sciences, physics in particular, after that, while still being involved in theological aspects, which I continue to be. So even here at Baylor University, I'm a member of the Center for Christian Philosophy, a fellow of it. I'm also a fellow of the American Scientific Affiliation. The content of it is better described by the Canadian sister branch, the Canadian Christian and Scientific Affiliation. It's also connected with Christians in Science in Britain.
So there's definitely the faith background there in family, as well as it sounded like, some engineering with your dad. And then when you got into college, at least for undergrad, there was the Christian aspect and faith aspects there. Going to Caltech, Caltech, you obviously ran into some pretty top physicists, but also I'm guessing folks who were maybe not sharing your belief in God or in, the specific Christian faith. Were there any challenges there? Were you concerned about sort of people looking on maybe at your Christian or background and having any kind of prejudice there or anything? Was there any kind of concern as you were going into Caltech and then into future career in industry? Did that come to a head at all for you?
In the sense that it inspired my continuation in science and theology areas. And in particular, when I heard some discussion between a Nobel laureate and another, or I would say Nobel laureate level, discussing Christianity, and their criticisms of it with regard to each other were summarized in the question, if Christians understand this physical universe so poorly, why should I pay attention to what they talk about theologically or spiritually? And that has been a deep question and something that I have been very concerned about since. And that is educating, bringing up many branches of Christian churches and denominations to understanding and acceptance of the discoveries of modern science.
Right.
And that includes the knee-jerk reactions that many denominations have taken with regard to the claim of evolution as the origin of humankind and of all life, and the negative responses to it. And not just evolution of life, but also evolution of the universe.
Right.
And there have been telling studies in surveys over the last decade or so that are very concerning to me about the connection or lack of connection between science and theology of many denominations. And also the response that the young adults in Christian churches today view in terms of the churches and their connection to science. And according to one recent survey, a third of youth adults with a Christian background believe that churches are out of step with the scientific world we live in, and a quarter of them believe that Christianity is anti-science. Perhaps as telling, there's been another recent survey conducted by the Associated Press, GfK, that indicates that Americans have more doubt than acceptance of concepts far away in scope and time that we scientists accept as firmly established by overwhelming evidence.
Right.
For example, over about 50% of the U.S. population disbelieves in Big Bang origin of the universe about 14 billion years ago, along with doubting the 5 billion year age of the Earth and over 3 billion year evolutionary history of life on Earth.
Right.
And unfortunately, there is the confidence in the well-founded scientific theories, all strongly supported by evidence, tends to decrease sharply with increasing theistic belief. Evangelical and fundamentalist Christians in particular express much greater doubts. And based upon another recent Gallup survey, more than 2/3 of those who attend weekly religious services espouse belief in a young earth compared to just 23% of those who never go to church.
Right.
So I am concerned about educating many fundamentalist and evangelical denominations of the wonder and glory and beauty that can be seen in the universe and understanding science. Yeah,
and it seems like it comes from both ways too. So, I mean, on the atheist non-believer side, they will look at evidence like that and say, well, I'm going to have concerns about your scientific views if you say you're religious because of some of that data that you mentioned, and then also, their faith in there not being a God. So, I mean, there's lots of people you see out there on television. I mean, Sean Carroll, I think he's also a Caltech guy, I think. Yeah,
he is, yeah.
He's not as extreme as some people. Like obviously you got Lawrence Krauss and Richard Dawkins who are on the attack on one side, and then like you said, within the Christian faith, a lack of understanding. I mean, what are some of your thoughts as to, first of all, why is that?
One thing I want to comment on. Both of those extremes take the same position in some sense. Mm-hmm. It's just who's right. Each claim to be right, but both of them are essentially claiming it's an exclusive God as creator or science, that it's an either this or that, rather than God and our scientific understanding of creation. There's no inconsistency between the two, and that's the primary message that I try to present, and that's also the predominant message of groups like the American Scientific Affiliation. We're trying to show that there is consistency between the two. And that's going back to the idea of the two books, the book of nature, that is, and the book of Scripture.
Right.
That if there is God as creator of all things, and we should expect to see and demand consistency between all types of truth that we study.
Yeah, and I think some of it has to do with the messenger as well, and so that's one of the reasons we have you on the show and other Christians and believers, to bring them up as other voices, because part of it is in the media. Mostly, you hear from those other folks that I mentioned, or in science shows.
Yeah, you hear from both extremes, but sometimes the truth falls in the middle.
Right.
And I think we are there.
Right.
We don't speak as loud enough or are not focused on because we're not as controversial. Controversy brings news.
Right. Yeah, it's usually people trying to sell books, and so the more controversy, the better. the more the books sell. Okay, transitioning now and talking a bit more about your specific research related to cosmology, string theory, quantum gravity. How have faith and science worked together to support each other in your work?
The way I see all of these, and one thing I'm doing in fitting all these in, is I see the development of human understanding of reality as enlightening and informing of faith for Christians.
Mm-hmm.
And the way we see that, if we look at the development and the stages of perception of reality that humankind has gone through, we can see with corresponding to all of those a better and fuller understanding of God as creator. I won't say that those provide evidence for God as creator, but instead for the theist, they provide a better understanding and fuller understanding of God as creator that is already fundamental to one's faith. I won't try to say that science will convert, but I think science, our understanding, presents a more full picture of God as we look at our growth in the scientific understanding of the universe. Mm-hmm. We'll start out with prehistory civilizations and their perception of basically what I'll call a regionocentric, or sometimes also mythocentric view of creation, the early myth stories of many different early civilizations. Mm-hmm. Up until a few hundred or 1,000 BC, in particular get down to about 300 BC, when the Greeks began a scientific or pseudoscientific understanding. And on the scientific side, they understood a geocentric picture. They really understood that the Earth was spherical. Eratosthenes was able to measure the radius of the Earth to within about 10% uncertainty. With that, our understanding of reality grew. Our understanding of God likewise as creator. Eventually we went on to a heliocentric picture of creation, much more grand than the geocentric, and this also broadened our view of creation and God as creator. Eventually we went on to the galactocentric view, beginning to realize the vastness of creation. Even as Einstein developed his special theory and general theory of relativity, he was still at the point of galactocentric. By the 1920s, we went on to what I'll call a universe-centric, the perception, realization that our Milky Way galaxy was just one of trillions became the dominant, until in the last few decades, we are, I think, up to and beginning a new paradigm shift, a larger one, to the reality that our universe may be just one of many. Now it becomes part of a multiverse picture. And this is where my research fit in and where string theory fits in. String theory strongly supports and predicts that our universe is one of a vast number. And different quantum gravity theories have some different predictions in scale, but they're all just a vast number. String theory in particular suggests that there is somewhere, universes defined by different physical laws, somewhere around 10 to the 500, and that's a one with about 500 zeros after it, all physically distinct universes. And when we get to that stage, I think for the theist, it shows a vastness of creation that we've never really considered before. But I think it's really putting us up to the scale of a grandeur of God as creator that we need to bring ourselves to.
The non-theist would or might say, and I've heard it said, over that time, at the same time, that also somewhat minimizes, if you look at it in a certain way, it minimizes man or mankind or humankind in the scope of things. So if it's all just Earth and everything else is around, surrounds Earth, it's all about Earth and humans being the primary creation and now rulers of the Earth. If you now expand it to not only a universe, but potentially, as you said, 10 to the 500 other universes, it opens up obviously a couple of other questions, right? So humankind's created role in that, and then are there other places where life exists in those other universes?
On the other hand, to me, imagining saying that the finite number of human lives on Earth over a finite time is not consistent with a God of infinitudes and omniscient, omnipotent, all of the omni properties.
Mm-hmm.
To me, finite number of lives on Earth over a finite time span is more in league with the very finite, limited concept of Greek gods. If we really think of the vastness of the Christian God that we believe in, who is creator of all things, beyond all things, transcendent. As was discussed by Robin Collins and myself when we were interviewed by Christianity Today back in 2010 in an article called Christ for the Klingons, that we were suggesting that the God of the omni properties is not consistent with anything less than a vastness of creation and a vastness of sentient beings to interact with. An infinite God who interacts with its creation in some way would not stop at a finite number of creatures over a finite time.
Okay. So you're in the definitely high possibility, or you're even saying probability of life outside of Earth.
I think both life outside of Earth throughout this universe and probably likely within our galaxy, but also probably within the multiverse picture, an abundance of sentient life.
Well, on that note, again, I'm kind of driving back here to the things that you've been working on, some of the more technical science things. So tell me about some of the propulsion things that you've been working on, because that seems pretty interesting in terms of interstellar travel. And then do you think within our lifetimes, NASA or some company will launch some kind of an interstellar mission?
Not sure exactly the length of time. It could take longer than currently planned, but the Breakthrough Starshot, funded by Yuri Milner, and the details of the physics aspects are being worked out by people such as Phil Lubin at University of California, San Diego, I think is a realistic proposal for interstellar travel. The one aspect of it that isn't exactly the type commonly thought is that the Breakthrough Starshot involves propelling by lasers these square centimeter sized chips that basically would be using current iPhone technology, or iPhone technology as developed within the next few decades, to launch thousands of these at a few likely known solar systems that contain Earth-like planets. It's been proposed that just through laser propulsion, these small microchips could be accelerated to roughly 2/10 of the speed of light.
Wow.
So that means that 2/10 is 1/5 the speed of light. The closest star system is 4 light years away, so that's talking about 20 years travel time. I think it's a viable project. There's many technical issues that have to work out, but none of them are significantly beyond current technological levels. So I think those will come much sooner than any type of interstellar travel involving human participation.
Right. That is obviously a debate as well. And Elon Musk and many others are really honed in on putting humans into space, and not only into space, but potentially to Mars. What's your view on that in terms of, if you have limited dollars in terms of investing in these things, human space travel, if you had to put it up against, robotic missions? To me, at least, it seems more productive on the robotic side, but I know there's different opinions out there.
I would agree with that, too. I think the robotic side of exploration of Mars, too, especially as autonomous systems are being developed. I mean, we're promoting autonomous systems for travel here on Earth. It will be much more advanced for doing that. Ultimately, I think human travel to Mars, will be possible, eliminating some of the more serious issues such as radiation exposure along the way and all that. Personally, I've sort of changed my position a bit and falling more on the autonomous system development first.
Right. So for these interstellar missions, so maybe 20, 30 years out in terms of launching one, maybe 10 years out in launching one, and then it might take 20 or 30 years to get there, and then, 4 to 10 years to get any information back. So we are looking at a good 50 years probably, it sounds like.
Yes, I think my lifespan, I don't think I'll be around when the signals come back.
Hope so.
I think our next generation, our children could.
That's right. Maybe get a message from another star system.
I think basically we're talking 2 generations.
Unless there's some other breakthrough, right, in terms of the opening up a wormhole, or is there other things that you've looked at outside of the laser propulsion that could get us antimatter or something, drives or something? I thought I saw that you've worked on or thought about.
Yeah, I've done some research on there, and I have as one of my research colleagues now in my group here, Eric Davis, who is one of the leaders in advanced propulsion science. Recommend a book that he co-edited with Mark Mills, a former director of Advanced Concepts Division at NASA. They have a book called Frontiers of Propulsion Science. about a 700-page tome, actually, I should say, that investigates a full range of aspects of advanced propulsion systems, full range from matter, antimatter to things investigating possibility of wormhole and all. And in fact, Eric is working with me here. He's a member of UCOS. He and I are working with several of our graduate and undergraduate students here on theoretical understanding of features required of a wormhole for travel such as that.
That one seems a little tough to swing.
Yep, I would agree. But I've been predominantly a theorist, working more in phenomenological studies now. But something like that it's intriguing to do theoretically.
It's exciting and interesting stuff. And let us know how those are going.
And it's very much at the stage of computational studies.
Okay, let us know if you discover how to create a wormhole. I'd love to be on your list of people you call when you find that.
Okay,
answer to that one. And then
I'll
also
contact you from the other side.
That's right. You can send the information to me from the future to the wormhole. So, and then how about some of these other theories? String theories, M theory, you talked about quantum gravity. It seems like things that we've been working on for decades. Are there, in your view, any kind of discoveries or experiments or things that would really move us further along in our understanding in these areas and get us closer to some kind of grand unified theory, some kind of consistent theory of quantum gravity? What's your view on sort of the future of some of these really big
There have been different proposals for quantum gravity. String theory, and when I say string theory, it actually evolved into what's now known as M theory in the mid-1990s. I did string theory again for my PhD thesis back in the late 80s, and those of us who have been in it since then, we still say string theory, although what we actually mean is now the new version of it called M theory. It's one of several approaches. There's also something called loop quantum gravity, causal dynamical triangulation, which is a computational approach which has been successful, and on. Probably around a dozen different proposals that are viable, possibly different, possibly connected versions of quantum gravity. I know there's amazing connections between the different proposals have been found in some significant papers in the last few years that in the end, if quantum gravity is fully understood, it may show that all of these are in fact related. We don't know. It's a theoretical exploration. At the same time, one of the things that my colleagues Anjiang Wang in physics here, Klaus Kirsten, and Tim Shen in math at Baylor are working on as a combined research group are developing ways of making predictions of all of these different quantum gravity proposals. And we're looking for ways that may show up in variations in, say, patterns in the cosmic microwave background. And we're not the only group. Several are doing this to develop some method of experimentally detecting the differences in these theory. And it's a very, very detailed aspects that right now we don't have the detector capability. We're really talking probably 1 or 2 generations away.
Right.
But we think it is possible. And I say not just we, but the whole field. And the other way that may be testable now that's developed significantly is detection of gravity waves. With the detection of the gravity waves from black holes and now neutron stars and the Nobel Prizes that were awarded to it. I think it was very appropriate that Kip Thorne was one of the recipients.
Right.
I had general relativity from him at Caltech and really appreciated his lectures. I think it's an amazing advancement in that field. I think all of these things working together will help cosmologists develop an understanding of the deep time, Big Bang and pre-Big Bang in status of the universe. And how early are we talking? We're talking, when we talk about Big Bang, we're talking within a time of about 10 to the minus 40th of a second after what we'll call time zero, the start of this universe. Really small. We're talking a scale size of the observable universe compared to 14 billion light years now. We're talking the length scale of the observable universe down to something as small as 10 to the minus 33 centimeters.
Wow.
Sounds like a small number. How does it compare? We'll realize that the nuclear scale is only 10 to the minus 13 centimeters. So we are going a billionth of a trillionth smaller than the nucleus of an atom.
Hard to get makes my brain hurt. Hard to get my head wrapped around that type of whether it's on the small end of the scale or on the large end of the scale. It's pretty hard for
it is, yeah,
pure humans to even contemplate something like that.
It is, but that's where science has enabled us to understand, and that's where I think there's a real need for churches to come to an understanding of our knowledge of the physical world and to allow that to inform us of aspects of theology too, and of our interpretation of Scripture.
Absolutely.
And that's one of the themes of the Lutheran Church and other denominations too, is faith informed by reason. We could replace reason with scientific discovery, human knowledge.
We like to even in Purposation even take it to the most basic level of Scripture and say, well, look at the two greatest commandments, to love and serve God and with all your heart and your mind and your soul, includes your mind, right? So, and also, to know more about Him. What better way to learn more deeply about God than through science? That's the way to see God, and as you said, the book of nature. And then also the second commandment, to serve each other. What better way to serve each other than to come up with discoveries that can help and cure people and cure disease and so many other things that God can use science for in helping others as well. So it's not only something that we're encouraging people to do, but we're saying, hey, this is sort of part of what God's telling us we must do as well.
I would agree. I think that's our calling. I think we've been given so much freedom, and I think that's one of the greatest gifts. That sometimes we fear the dangers of this universe that can happen around us, but I think all of that is part of the freedom both of sentient beings and of nature itself, and us living in it.
Amen. So talking about some of these deep science questions, so M theory and quantum gravity and some of the other the things that you've talked about, and some of these deep questions about the very, very, very beginning, or pre-Big Bang beginning, deep questions that have taken decades to get to the point we're at, and probably will take a few more decades to get to even further along. If you could choose one of those deep science questions to ask God, is there one that you could pick out and say, God, I'm really struggling with this one. Could you just go ahead and give me a shortcut? What would be the answer to this problem?
Yes, but at the same time, I think it goes beyond science too. And that question that I would ask is, what is the totality of physical reality? And it has to do again with this understanding of reality and through the stages that we've gone. Again, starting with a regional-centric, close view of reality around us, 3,000 years ago, to up to the universe and multiverse stage now. And clearly, how much does reality go beyond that? And including, and as I said, it goes beyond just science when we consider the theological aspects of it too. Mm-hmm. What is the concept of heaven? Mm-hmm. What does it really mean? I think we all have very primitive views. I think it's one of those questions, if we imagine it, it can't be so. Along with that also, what is the ultimate understanding of time? And time beyond this universe, and if we have a multiverse, time within each universe within a multiverse is totally independent of time within any other universe. And I say that flippantly, but that's arguably true on physical grounds and grounds right. for general relativity.
Right. So you're asking him for the full textbook here, it sounds like.
Yep, I am.
You're like, no, I don't want the the chapter 4 paragraph 2 answer. I want the whole the whole enchilada. Yep. Okay, well no, that's a good one. I mean, so yeah.
And the third question I would ask.
Okay, you
totally
got 3
beyond.
Now. I said 1, but okay,
yeah, totally
ahead.
Beyond physics or science. And I would ask God, how do you perceive your own existence?
He could tell you, but you wouldn't be able to understand.
But we wouldn't understand.
It will be meaningless to you.
Yeah.
Those are all great ones, and yeah, I mean, sort of understanding, how we fit into all of it too, I think would be a big. Yep. So great questions. Shifting gears a little bit. So we talked a little bit about Christians getting more knowledgeable about science and understanding these issues and having an interest in not putting up the barriers, that a lot of people will do based on fears or concerns or, maybe disagreements or perceptions of disagreements, either scripture or faith. So assuming we've, gotten past that and we've got people who are interested, who are Christian believers, strong believers who are interested in science, mm-hmm. young people or people maybe who are entering college, considering entering college, and what are some things and advice you might give them in pursuing a career in science or in physics?
I would say if they're entering college, they may have already decided on their major, they may have not. My advice for each of them would be go in the direction where your passion is calling. Love what you do and do what you love. Mm-hmm. I don't think there's any more substantive advice than that. I think that's at the heart of success.
So looking back for you, is there something in particular that you can think of in your science career, at least, where maybe you saw the hand of God or some miracle or some, guiding, voice or something in your life or in your career where you're thankful to God in kind of moving you along in a certain direction or helping you along the way?
I think the opportunities we encounter, and at the same time, not just the science part, but I think opportunities with family. I think the human side always goes beyond the science side. So I think the most thankful for is family and friends.
Any closing thoughts on moving forward in the topic of faith and science?
I think it's a broad and growing topic, and the understanding and connections between science and theology. I think it's something we need to understand as developing and never finished. I think one of the problems at times is when people think that our theological development is finished or the science development is finished. Both are ongoing processes that need to be worked and developed together, just looking ahead always for the growth in all things.
And hopefully more open dialogue, I guess, and being open to hearing differing points of views, not closing yourself off, whichever side you fall on, I would say. And that's obviously become very divisive in this country, at least.
I would say, unfortunately so, the divisiveness and the conflict rather than seeking understanding and acknowledgement of differing views.
Amen to that. Well, thank you so much, Professor Cleaver, Jerry, for your time, and just really appreciate it.
Thank you, Brad. I very much enjoyed it.
Thank you very much for your service in the sciences and obviously in proclaiming Christ, and hopefully you and your team there at Baylor and your family and will continue to flourish and may God bless you.
Likewise. Hey, good talking. See you, Brad.
Thank you for joining the Purpose Nation podcast. For more great interviews, resources, or to make your tax-deductible contribution to support our nonprofit ministry, please visit purposenation.org. This program is copyright Purpose Nation, Inc., a 501c3 nonprofit corporation.
Suggest otherwise, and
Okay.
some suggest that at the beginning of time it really was what we'll call time zero, but that there was likely even time within our universe preceding that.
Interesting. Okay. Well, I'd like to hear more about that in a minute. Now, so you're also at Baylor University, and how long have you been there?
I came to Baylor from Texas A&M back in 2001. Following my earning my PhD in 1993 at Caltech, I did postdocs at Ohio State University, University of Pennsylvania, and then Texas A&M for 2 years, and then visiting assistant professor for one, and I came to Baylor from there.
Right. Great. And they're a Christian university, yes?
Baylor is, yes. Baylor is affiliated with the Baptist denomination. And I say affiliated, it is most closely affiliated with the Baptist General Conference of Texas.
Okay. And now this is a graduate physics program as well. At least to my mind, it doesn't seem like there's a lot of, at least top programs. I know there's probably some programs that are undergrad, but in terms of graduate physics programs at Christian universities, are there many?
Each denomination tends to have at least one full university with graduate programs. And Baylor is the largest of the Baptist universities. Baylor likes to think of itself as, in some sense, the Protestant Notre Dame.
So obviously Notre Dame's Catholic Christian roots to it. They obviously have some top programs in science and physics. I wish there were more, I guess is what I'm saying, because it does seem like a great option.
We are trying to be one of the leading Christian universities with research. Decades ago, Baylor was predominantly a teaching university, but starting a little over 20 years ago, it began the transformation into a research university. And currently, we have Research 1 status, and our goal as part of the next 10-year program is to advance to, Research 1 is also known as high research. We are trying to advance to what's now classified by the Carnegie as highest research status. To do so also means basically increasing our rank to one of the top 50 universities.
Specifically for the physics department, it seems like you're definitely growing that, and the grants that you've gotten, it seems like there's a lot of growth there. Yes?
It has. We've been growing and developing quite well since 2000 or so.
Okay. Well, so take us a little bit back.
Welcome to the Purpose Nation podcast, inspiring conversations with Christians in science, technology, and industries of the future. For more information or to make a tax-deductible contribution, visit purposenation.org.
This is Brad Cooper with Purpose Nation, and today we are thrilled to be joined by theoretical physicist Professor Gerald Cleaver. Professor Cleaver, welcome to the Purpose Nation podcast. How are things in Texas going today?
They're going well. Thank you, Brad. Thanks for the opportunity, and just call me Jerry.
Okay, I will. Happy to honor our guests in any way they'd like to be addressed. So Jerry.
Okay, thank you very much. I appreciate the opportunity to discuss science and theology with you today.
Thanks again for joining us. Looking forward to it as well. Should be some interesting topics and discussions on faith and science, and maybe talk a little bit about space travel. I saw that on there, and that always jumps out at me, and so I saw some things there on your background. So first, by way of background, a little background on Professor Cleaver. He is a professor and a graduate program director in the Department of Physics and division head at the Center for Astrophysics at Baylor University. He directs their research projects or areas of research that you're currently focused on.
My long-term research, again, continuation of the PhD that I earned way back in 1993 under John Schwartz at Caltech is a specific aspect of string theory. String theory is an interesting and controversial topic that suggests that the universe that we live in is not just three-dimensional, but has some extra but very, very small and essentially undetectable dimensions of space. And it proposes a version of sort of a grand unified theory that offers an explanation or description of all of the forces and particles that we find in this universe. More recently, I've been doing research with my colleagues here on something called quantum gravity, of which string theory is one possible direction in. We've been working on ways of detecting the state of the universe prior to the Big Bang.
That's definitely interesting because my impression has always been that there wasn't a state of the universe prior to the Big Bang.
Quantum gravity in various different approaches
or the early universe cosmology and strings division as well. And I guess that's UCOS. I don't know if that's how you pronounce the
UCOS as the acronym for it.
Okay. And then also Baylor's Center for Astrophysics, Space Physics, and Engineering Research, which the acronym is CASPER on that one.
Yep. Yeah, and UCOS is the division I lead in CASPER.
Okay, great. And I always love the acronyms in science.
Baylor loves acronyms.
And don't worry, we have a lot of those in the technology, in the tech industry as well. So acronym city. Jerry has written over 100 peer-reviewed papers and articles in many top-tier research journals and conference proceedings. He co-authored a book. He earned his PhD at Caltech, real top school for physics there. Lots of great names have come out of Caltech, including John Schwartz, who I guess is one of the founders of string theory. Is that right? That's somebody
that is correct.
As well. And he does focus on superstring theory and string theories, as well as elementary particles and fundamental forces. And as we'll talk about here, I hope, in a minute, some interesting interstellar propulsion mechanisms and things like that. So lots of great background there and some fascinating experience. Tell us some of the main things that you're working on currently. What are some of the main